Hi everyone, welcome to Kubernetes workshop. Let's quickly go through the agenda and how we will gonna do this workshop. So we will be doing a quick overview of Kubernetes and going through multiple details around it. We will be doing labs after that. We have a Google Meet session. So if you're planning to do labs with us, we would suggest join the Google Meet. Or if you plan to be an observer and just want to see how things work, feel free to join on the YouTube Live. If you want to have any troubleshooting taken care of, then feel free to join the Google Meet. Make sure you close or mute your YouTube when you join the Google Meet, and YouTube Live you can do parallelly. But the idea is you'll be doing an echo if you join the Google Meet and join the Google Live as well. So we'll be starting shortly. I just want to make sure everybody in the Google Meet also know how the process we are following. Okay, let's start. We'll start with a quick overview of Kubernetes. So Kubernetes, commonly known as K8s, removing the letters between K and 8, K and S, and making it an 8, is an open source container orchestration system for automating computer application deployment, scaling, and management. And yeah, that is a mouthful of words. What it actually means is if you have containers in the past, you're using LXC or some other tool to manage it, it was very cumbersome to build even few containers on a single system. Now, Docker made it very easy to spin up and manage the containers on a single system. So if you want to spin up 5 containers, 10 containers, it's fairly easy using the Docker. But nothing runs on a single computer or a single server because you want redundancy and scalability. So if you want to scale beyond one server capabilities, you need more than one server. And if you want to fail safe that server has an issue, you want to have multiple servers in there. And Docker does not have capabilities to manage multiple servers. There is another enterprise product by Docker, which helps doing that. We will cover that in a future or some other section. But here we're talking about another tool which manages the containers on multiple servers. It uses Docker as the underlying system, although in the recent time frame they have changed the default container management to some other tool. But the role of Kubernetes is not to just manage the containers; it manages the cluster itself, which runs the containers inside it. And you'll get more understanding as we go through the labs and more details. So it all started with Project Borg, which was internal in Google, and then Omega, and then Google made it an open source. So origination of it was from Google with the Project Borg. It is also Linux kernel of distributed systems because with containers, what we're doing is we're virtualizing the Linux container. Oh, sorry, we're virtualizing the Linux kernel. If you would have seen in the yesterday's session or check the videos on our YouTube channel, you'll see that a container is actually virtualizing the operating system. So in the VM, if we have one server with 10 VMs, we have 10 operating system running on it. In the container environment, we have a server, we run the operating system on the top of it, and 10 containers just leverage the same kernel. It decouples the infrastructure and scaling becomes very simple and it's very dynamically, you can increase the um, application. It becomes self-healing because it's declarative. So if you tell Kubernetes, I want to run 10 pods, pods is the smallest unit inside Kubernetes. And if you write the YAML file and inside it, you say, I want to run 10 pods of an application, and one of them goes down, Kubernetes will gonna bring it back. So you don't have to worry about managing those things. Kubernetes will take care of it. That's why it's self-healing. So it'll always try to steer the cluster to its desired state. So if you say I want 5 healthy instances of Redis to be always running, and it'll make sure. And if the one instance died, it'll gonna spin it up either on the same server if feasible. If not, it'll gonna spin it up on the new server. And everything for the others will gonna be seamless. You can auto scale workloads. You can do a blue-green deployment, fire off jobs scheduled and cron jobs. You can have stateless and stateful applications. It has native method for service discovery. We'll be covering that in future labs. We are working on those labs for Kubernetes services, but soon they will be releasing those and you'll have access to those. So it uses an API for everything, and it is the same. So whether you run the Kubernetes in your cloud or on your server, could be a bare metal server inside your private cloud, it'll be using the same API. Now, who manages Kubernetes? It is managed by Cloud Native Computing Foundation. It's a child entity of Linux Foundation and operate as a vendor neutral governance group. It has a lot of stars on GitHub and more than 2,000 plus contributors. Now, what is a Kubernetes cluster? Essentially, it is a group of servers which are node in Kubernetes terms. There will be one master node which will be managing the control plane. So no data will be going there. There will be some pods, which are in turn containers running on this master node, which will be managing everything inside the Kubernetes. And then there will be nodes or worker nodes where actual pods will go and spin up. Now, this is the internal architecture of Kubernetes. So in the control plane, we have components like API server. Anything you do in Kubernetes goes through API server. So any request you run via kubectl, any other tool, or you run a YAML file, it will be sent to the API server. And then API server in turn will make the call to the different components to get the thing running as you have defined. And Cloud Control Manager, as it states, it manages the multiple clouds if you're running a single control plane. Controller Manager manages all the other controllers inside it. We'll be covering those, and we have a lot of videos on our channel which covers those in much greater details. Now, kubelet is the actual code or the binary which runs on every server and which manages the container manager. So you have containers which are managed by Docker or another container management software, and kubelet make the calls to that container management software to bring the container up or to bring it down, delete it, whatever is desired by you when you put the commands in. Those are given to the API server. API server internal makes a call to kubelet. Kubelet makes a call to the container manager. kubeproxy runs as a software which manages the network connections, and it runs on every node. But all the other control plane components run on the worker node. Now, pod is the smallest unit of work in Kubernetes. A pod could have a single container or multiple containers. but it'll have its own network space. It could have external volume attached to it, and it could have a pod network which will it'll attach to. They're ephemeral in nature, so if a pod goes down, you will not be able to maintain the state with it. But there are ways when you connect to the external volume, your information, whatever is in the volume, will be maintained. So there are stateful set or other ways to manage the information and retain it. But in general, a pod, when it's lost, if it's deleted, you will lose all the information from it. So generally, if you have a web server which takes your request and send it to the API, if you lose that server, it doesn't matter because some other server will take care of the same job. Now, services are like a load balancer. Now, how they work is you have a bunch of hosts with a bunch of pods in there, and there are labels on it. And the service, you say that, hey, group the pods, whatever the pods have these two labels. In our example, we're giving app is equal to Nginx and environment is equal to prod. So these will be grouped together. And as per the policy we define to load balance between them, the traffic will be sent to the service and service will send to the one of the pod. And service stays there. So service is kind of a permanent thing unless you go ahead and delete it. So, okay, that was the brief overview. Now the next phase, we will be open for any questions you might have, and we'll proceed with the labs. So all the labs are hosted on our website, sharelearn.net. Um, and the way to reach them is if you scroll down on the homepage, there's Kubernetes Labs. And also you can go via practice and you can go to the Kubernetes Labs. Now, you would have to log in. It'll ask you to log in the moment you put start lab here. It's just a Google sign in. So it's very simple. You just click it, pick your Google account, and you should be able to access the lab. For the labs, the we host the steps, but the lab environment is actually hosted on Docker environment called Play with Kubernetes. And for that, you would need a Docker user ID. That is part of the steps as well. But as we are going through the workshop, I would suggest go to the docker.com and then click on sign up. Um, it's fairly simple. So if you, in my case, I'm logged in. So if you go here and log in with your, create a Docker ID and put an email and a password, sign up. That'll give you a Docker user ID. It's free of cost. Play with Kubernetes is free of cost as well. So you don't have to pay anything for that. Same thing on the Share Labs. Most of the labs we're discussing here are free of cost. In future, we might have some labs where very complex labs, which will be using very specific practical scenarios and require different things to spin up. Our idea is to bring those in the public clouds. So those might be paid per. So far, we have all the labs are free of cost. So let's go through the lab 101, where we will be building a single master cluster. So in this lab, we will be creating a Kubernetes cluster from the scratch. Some of the things are already done because this is 101, so we don't want to go in too much details here. All the labs are hosted outside, so you don't have to install anything on your computer. So first step, just give you an overview that what we're doing in this lab, we'll practice building Kubernetes cluster with a single master. And the next, it asks you to create a Docker Hub account. You may skip this step if you already have one. So, and here it asks you to open Play with Kubernetes. Next step is to log in with your in the drop down, select Docker and then log in with your Docker account, which we just created. So once you log in, it'll give you the start option. And as the step indicate, let's click on the start. Next step is to, it just states that it will start a 4-hour session for you. Click on add new instance. So it'll create a virtual machine for you in the background, and we're going to give you the details or the terminal of it. Once you're there, let's go to the next step. And with this step, we're going to initialize a Kubernetes cluster, and the command for that is kubadm init, and then we're defining our API server address as the local host. So this host will act as the API server, and you have to tell what will be the network subnet you'll be using for your pods. Here we are giving 10.5.0.0/16. It'll take a minute or two to spin up things. Here in the backend, Kubadm is instructing kubelet, and kubelet is instructing Docker in the backend to pull the images of the control plane pods and create those pods for us. If you have any questions, feel free to put them in the chat, YouTube chat, or if you wanna, if at any step of the labs you feel it's not happening, the same thing is not happening in your lab, feel free to join the Google Meet, and I'll be happy to troubleshoot with you. And our idea is to give you live setup rather than just screenshots or a scenario where we pre-fill the answers for you. So everything will be unexpected. A lot of unexpected things could happen while we do these labs. That's why we have this workshop. So you can feel free to join the Google Meet, and we can troubleshoot with you. We can go through the next steps while this is going on. Now, it once this complete, it'll give you an output with the kubeadm join, and it will give you the token, the discovery token with the SHA-256. We need that to be able to add the nodes to the cluster. So that is very critical information we would need to have. So don't, I mean, that's what we need to copy here. Let's see. Oh yeah, this has been completed. So if you see this part, kubeadm join, and then the IP address with the port number 6443, this is what we need to copy. Um, and you might have to do it with the right click if it's not doing it with your commands. There is some issues that you could face if you're using a Windows computer, but there's not too many alternate. Just try to copy it and see if that helps you. Okay, so let's go to the next step, and this will be checking the status of the nodes and in the cluster. So right now, there's only one node, but we want to check what is the status of it. And it says there is a node 1, which is in the not ready state. And the reason for that is we have deployed our master, but we have not put the CNI, which is the network interface for the Kubernetes. That's what we're going to do in the next step. So here we're deploying a CNI, and we'll be covering CNI in the future labs, but for now, use this command. What we're doing is we're using kuberouter. Here we're getting the YAML file for the kuberouter from the GitHub and deploying it in our cluster. So if you go back and check the node status, we're still waiting for the CNI to get deployed. But once the CNI get deployed, it will change to ready. Let's look at the next steps while this is working. So next step is to check the node status again. It should be in the ready state for us. We're still waiting for that to happen. In the next step, we're going to create the second node. So let's click on the add new instance again. In the lab, we'll be going through the second node and then creating the third. But for the workshop's sake, let's create the third node here itself. Let's look at the node status. Okay, so our node has changed to the ready state because our CNI has been deployed, and we're good on that aspect. Now we're good on the step 9. Let's go to the step 10. Here, do not copy this command from the lab because you have this command output is unique for every cluster. So this QVDM join, you have to copy from here. So it'll not going to help you if you take this output from lab on the screen or lab on our website. This is very specific to every cluster. So we copy this, we go to the new node, and we paste it over here. So it'll gonna do a few steps on that node, and this is the only time we'll be going to the worker node. And it gives you a message, run kubectl get nodes to the control plane to see the nodes join the cluster. And it actually has done its job on this node, so it is part of the cluster now. Going forward, you don't have to do anything on this worker node. You'll be going to the master and making the changes over there. So let's add the third node as well. It's the same command. You copy on the third node as well. And feel free to add more nodes if you want to practice. But in this lab, we're just going through the 3 nodes. And every lab after 101 we'll be doing, we have to do these steps because anything you do, you would need a cluster. You cannot create a pod or deployment unless you have the Kubernetes cluster already set up. So let's go to the next step. In this case, it asks you to have the join node and then check the node status again. We have done the join node on the 2 of those, and both of them have been successful. So if I do kubectl get nodes on the master, now we see 2 more nodes have been added, and they both are in the ready state. Let's go to the, so here we're doing the same steps on the third node, but we have already done that in the workshop times, and we have all 3 nodes active and ready. So that completes, you got 3 nodes cluster, single master created. If you want to practice a little more, you can add a few more nodes. Um, this setup, Play with Kubernetes, will let you add up to 5 nodes. So feel free to add if you want, but most of the things we'll be doing, most of the labs are covered within the 3 nodes. So you should be good with that. And when you so the 15th step was the cleanup. We will not gonna do cleanup during this workshop because we'll be using the same setup. So in case of cleanup, what we're asking is to delete this node and the other nodes and then close the session. And if you have any confusion or you want to check back how these steps work, you can always refer back to this YouTube live or the YouTube replay, or you can go to this YouTube video and this will show you the steps which we have done. So let's click on done. We get back to the Kubernetes Labs page and let's go to the Lab 102. So in Lab 102, you're going to see that create the Kubernetes cluster is the first step because you cannot do anything in Kubernetes without a cluster being present. So here the hint is go to the Lab 101, and the solution is all the steps we have done in Lab 101. So we already have the cluster set up. Let's go to the next step. So in this case, it's asking us to create a pod using kubectl command, and it's giving us the name and the image which we're going to use for the pod. Now, if you have any confusion what the container image is, I would refer you back to on the YouTube channel. We have a Docker workshop which happened yesterday, which give you clarity on how the image and everything works. But in our case, these are the instructions given to us. And if you look at the solution, it'll show you that you have to use kubectl run command, and you have to say that the name of the pod, which in our case is provided as web, and then you have to say image is Nginx. So if we take this and take it to our environment, everything runs on the master. So we're not going to go to the worker. They'll still be running in the background, but we'll not be going back to them to run any command now. So on the master, I run the command kubectl run name of the pod, web in our case, and then an option of image, which I tell to use Nginx. And the response was pod web has been created. So it the step tell us to verify our step with the command kubectl get pods. And we see here there's a pod being created, and it is in the status of container creating. So it should get to ready one by one, and it should be in the good status. Container creating is not the one which we want. It takes some time to create a pod in the real time. So while this is happening, we can go to the next step and see what is the next step we have to do. So now it is asking us to delete the pod using kubectl. And the command for that is simple, kubectl delete pod and the name of the pod. Now understand, we are going through these steps to understand the pod and other commands, but in the live environment, you'll not be using kubectl, and especially you'll not be working with individual pods. So let's see if our pod has been created. Okay, so it is ready. We see one by one. And so that is how many containers are inside that pod and what state they are in. It tells there's one container and it is in the ready state. The status is running, so we're good. Let's go to the next step and delete the pod using the command kubectl delete pod and then name of the pod. It gives us the output pod web has been deleted. So if we verify that by running the command kubectl get pods, it'll tell you no resource found in the default namespace. Okay, so our next step is to expose pod port with kubectl. So this step is asking us to create a pod using kubectl and expose the port. And the port number has been provided, the name of the pod has been provided, and the image has been provided. And the command to verify is kubectl get all. We'll go through that as we go through this. So the solution for this is kubectl run name of the pod, the image which we just use an extra option of port is equal to 80. So if we take this and go back to our master and paste it, it shows us that a pod has been created. If you want to verify it with kubectl get all. Now get all, we're going to give you output of a lot of things which are running inside the default namespace. As in our case, only two things are running, a pod with a web, which container is in the creating state, and a service, uh, Kubernetes, which is cluster IP type. We'll be going through those details and further. While the container is still in the creating state, so let's go to the next step and see what is the ask over there. Okay, so we have a running state pod. We're good on this one. Let's go to the next one. Here, it's asking us to expose the pod outside the cluster. So if you see here, you have a service, but it's of type cluster IP. There's no external IP here. So you cannot access this service from outside this Kubernetes cluster. Internally, you should be able to access it with the DNS name and with the cluster IP we have. This will remain the same unless you go ahead and delete it. Okay, so let's go and expose the pod outside. And for that, we're going to use the command kubectl expose. We use the, as we are exposing the pod in this case, we put the pod, name of the pod, what port internally has been exposed by the container, and what port are you exposing it outside, and what port will be the target port. The type of the service we're using in this case is node port. That's how we expose the container outside the Kubernetes cluster. And we are naming this service as nginx-service. Okay, the service has been created. So if I do get all again, you'll see there is a new service has been created, and it has a port number 32544. This will be unique for every setup and every time you run it. So if I expose it again, I might not get this port. Now let's go to the next step, and it's asking us to find the node port, which we've already done with the get all. So we know our port is 32544. Let's go to the next step, and it's asking us to access the container port using the browser. Now, how we do that is we take in an environment which is outside this lab, you will be picking any node inside the cluster and putting this port after it. So if I take this URL and go to my new tab and put :32544, I should get welcome to Nginx. This is coming from that particular container. Okay, so that exposes our Nginx port 80 on a port 32544 outside the cluster. So now you can access it from outside the cluster. Internally, we have a cluster IP service. Outside, we have node port. Let's go to the next step. So now it's asking us to create a node port service. And the difference between expose and a node port service is in a node, when we are creating a service, we can define what port it should be exposing the service on. As you have seen in the previous example, the cluster randomly gave us 32544, which might not be a very feasible solution for us. We don't want to rely on cluster to give us a random port. We want to do it on we want to define what port should it be exposing it on. So in this case, we're using the command kubectl create service. We're telling it to create a node port service. We're giving it a name. We're telling a TCP of port number on the target and what container is exposing. And then we're telling the node port and we're telling it that expose it on 30,001. Now, that is the first port which could be exposed with the node port. The range is starting from 30,000 all the way to, I need to get the real exact number, but you can easily find it, what ports we can use. Here, we're using 30,001. So if I press enter, now the expectation is if I go back here, change it to 30,001, I should get welcome to Nginx. But that doesn't happen. And the reason for that is the labels. So the way it works is when we create the service, it uses the labels to expose the containers. Now, if we look at here, when we expose the pod, it matches the label in the backend. But when we are saying creating a service, the service doesn't know anything about the pod. We're not telling anywhere what should be the pod should be exposed. So if you look at it, the selector for the services that a pod should have the label of key app and Nginx service one as the value of that label. That is not configured anywhere. So far, that's the reason we are getting a page cannot be displayed on it. So in this step, we're adding a label to the pod, which is, and again, whatever you're watching here, this is just to give you a quick experience as somebody has asked. The thing is, you get practice this and you'll be going as you go through further labs, you'll be understanding what the services are in depth, pods, how the details are internal of the pods, how we abstract the pod with multiple things, replication controller, replica set, and deployment. And all these things we'll be covering in the next labs we already have on our website. Right now, we're just getting our hands dirty and just following the steps so you would know, okay, I created a service, but it didn't expose anything because there was no labels attached. So here we're saying kubectl label. We're telling it to put the label on the pod and name of the pod, then we're giving the key value pair. So in this case, we're saying the key for this label will be app and the value will be Nginx service one. And the moment we do that, if we go back and refresh our page, we see welcome to Nginx. So if we go back and do describe on our service, you will see that the endpoint has been found here because the label has been attached. So selector has looked into the system and found that there's one pod which matches my requirement and added it to the load balancer, to the group where the client should be sent. Again, in this case, we're just adding the label and verifying, which we have already done. Now, in a lot of things which we'll do next and Kubernetes, we use the YAML format to do any deployment. And let's say you want to get that format rather than deriving it or thinking about it. So one way to do that is we already know that if we do kubectl run, it'll gonna create a pod. And we give the name of the pod, we give the image, and then we say dry run is equal to client. That means don't do anything, just run this command and tell me if everything verifies, but don't make any changes. And then we give a dash O option and YAML. That'll give you the output in the YAML format. And we will be going through these in the next labs. And we already have videos on our channel which explains these in detail. But API version in this case is V1. The kind is pod. It could be any object inside the Kubernetes which you're trying to create. Um, Timestamp is created by the Kubernetes when the pod is created. So generally, we don't even provide it. Metadata, what we provided is the labels. And in this case, it's giving run and web and name and web. The specs is where the details of the containers or depending on the object, the details are configured. So here we have containers. We define the image as Nginx, name as web, and we have not defined the resources. We'll be doing that in future, and the DNS policy and the restart policy. Now, if you want the similar output in JSON, all you have to do is change YAML to JSON, and you can get the JSON output. Now, the next command is to figure out. In our case, we just have 3 nodes, so it's really easy, but you might have hundreds of nodes in your cluster, and you want to know where your pod is running when you're trying to troubleshoot. So what you do is you say kubectl get pods and put a dash O option and say wide. That'll show you where your every pod is running. Again, you can further put a pipe and grep and for a particular pod which you're looking for. But in our case, we just have one pod. So it's running on node 2. That's the answer we get. We also get the IP address used by this, which is 10513. which completes this step. And the next one is to delete the pod and look into git pods and make sure it's deleted. So if we do kubectl delete pod web, it's just to get the practice that and a good cleanup method as well. Whenever we are working on lab, we should not required, but we should remove all things we've created. Okay, so if we go back and look for get pods, we can even look at the wide with the wide option. It'll tell you no resource found in the default namespace. So our pod has been deleted. As in pretty much every lab, you will have a cleanup step, which will be to remove the nodes and then all the nodes individually. So delete this, then others, and then close the session. That'll give a better environment for others. And okay, and this lab also, most of the labs or the initial labs have the video in it, so you can look into the video and see if you miss anything while you're doing that. Okay, so as a time check, we have a few more minutes left. Do you want to go through another lab, or if you want to go to the Google Meet and tell us if you have any challenge or anything while doing this lab, we can do either or answer some of your questions. Okay, so the question is whether these labs are free. Most of the current labs and a lot of new labs which will be coming will be free from Share Learn Sign and will be free to work as well in the Play with Kubernetes environment. Both are free. You would have to sign up on our website with the Google authentication, and on the Docker you would have to create an account with them. Um, in order to access the labs, you can go to practice Docker Labs, which will give you the Docker Labs, and Kubernetes Labs, which will give you the Kubernetes Lab. We are still working on the Linux cloud and further Python and the other labs, which you'll see in the practice section. You can also go to our homepage, and if you scroll down, you can go to the Kubernetes Labs, and you'll get to the same page. You can see this without login, but the moment you're going to click on start, it'll going to ask you to sign in with the Google account. The sign in and sign up steps are the same. And once first time you go there, it acts as a sign up. And the second time you go there, it'll going to just sign you in with the details we already have. It also has a profile option. So the first time you log in, it'll take you to the profile page. And there you can edit the information on your LinkedIn, GitHub, Stack Overflow, and bio so that we can help you further if you want to. There's also subscribe to our newsletter, which is checked already, but feel free if you want to, for any reason, unsubscribe it, you feel free to do that and save here. We'll be very courteous on that, and we'll make sure that you don't get any newsletter if you decide to unsubscribe it. Okay, I don't see any more questions, and we are 15 minutes more. So I can go through the pod next lab, the steps in general, and if we have time, we can do that as well. Now here, as we discussed, it will ask you to create a Kubernetes cluster. The solution is the same as we have done in the 101. That pretty much lab is repeated. And for the workshop, we already have the Kubernetes cluster created, so we should be good in that aspect. And the next one, it is asking us to create a pod, but this time it is asking us to use a YAML file. In the last lab, we saw the YAML format, although in this case, the solution is pretty much given here. So what we'll do is we'll do a VI, that is a text editor in the Linux and Unix world. So we type in VI, name of the file, pod.yaml. We go inside it, press I to go into the insert mode, and then we can copy this output and paste it over there. And I'll explain you what these things are. Again, as we discussed, every object, every YAML file in Kubernetes will require four components: API version, kind, metadata, and spec. What goes inside them depends on what you're trying to create. In this case, we are creating pod. The API version for that is v1. The kind is pod. For metadata, what we need is we need the name and labels. So in our case, we're putting the name as demo and labels as demo and web. That comes from the step directions. And then in the specs, we are saying that name of the pod is demo, name of the container inside the pod is demo nginx and image is nginx. We're saying the port the container will be exposing in port is port 80. Okay, so that does that work. Now that creates the YAML file, but it doesn't apply it. We have to use kubectl apply -f, which tells we'll be using a file and give a pod.yaml. Now in the backend, kubectl is communicating to the API server and getting the things created for us. And it'll give us the message whether it encountered a challenge or it created the things for us. So if we go to the next step, here we're trying to go inside the pod. So we're trying to connect to the pod, but before that, let's verify our pod has been created. So we'll just use kubectl get pods. This time pod has been created. It's in the ready state and the running state. Um, okay, so let's use the kubectl exec. Now, exec is the option to use commands inside the container, and IT is the interactive and terminal option that we want to go inside and interact with the pod. We give the name of the pod and two dashes, and then you want to tell the applications which you want to interact with. In this case, we'll be going to the bash shell. So here we go. Press enter, and it'll connect, give us a prompt which is inside the container. We can run ls-la. These are the file structure inside the pod which we have. So now next step is to check the logs, and when you want to exit, you can run any commands over here, any troubleshooting you want to do with the pod or your application running inside the pod, you can do that. And once you're done with your work, type in exit, and it'll take you out. Now you're back to the master node. Here, if you want to check the logs, you can do kubectl logs and name of the pod. So this will show you the logs from inside the pod. These could be these are the application logs or the container logs itself, which are gonna come on the terminal. Now, let's say you want to follow the logs, because if you're running an application, Elasticsearch or Postgres or any of your application, you just don't want to look at the logs once, and these will be huge logs which will just go away. So you want to use -f command. In this case, it'll gonna follow the logs. So it's just spin up all the old logs and then show you the continuous logs. And once you're done, you can do Control C and it'll stop streaming those logs. The next step is to stream the logs, but we don't want to see the old logs, or we only want to see certain number of old logs. So we use the tail command for it, and tail command, we're gonna, in this case, show only one old log and then show the new logs to us. Our application is not doing anything much, so there's no logs being generated. So we're good in this aspect right now. Again, the ask is to find where the pod is running. We already know the answer as we have done it in the previous lab. We run the command kubectl get pods dash o wide, which will show that node it is running on as node 2. If you want to find the details on the pod, the way you do it is with the describe command. So you'll be doing kubectl describe pod and then name of the pod. So here it'll give you all the details, what is its IP address, if it is controlled by any other entity, replica set, or any other entity. So in this case, we get the demo, namespace is default, what is the priority for it, which node it is running on, what was its start time, labels, annotations, status, and a lot of other details have been provided here. So now, again, we have already done that, but let's say we just come up with the YAML file in this case, but you want to find out what should be the appropriate YAML file for any object. You can, in this case, we are finding it for the pod, so we are using the command kubectl run web. We are giving an image here, and you can give the labels as well, and dry run client. Again, dry run client, just tell the Kubernetes, don't do anything, don't make any changes, just show me the output works. And then dash o YAML, and it gives you the same output which we use in the YAML file. And if you want this in the JSON format, you just change the YAML to JSON, and now the output will be in the JSON format. Next one is to delete this pod, just to keep the system clean. So we'll use kubectl delete pod web. Okay, okay. So I think that's a bug here because we should be doing the pod demo. So if you find any bug, please help us to solve this. Click on report a mistake and use your GitHub ID to create a new issue and tell us if you find any issues in the lab, and we'll be happy to solve those as soon as we can. In this case, it should be the word demo here. So coming back, the pod demo has been deleted. Next step is to clean up, as we have discussed in the previous lab. It's similar, delete the nodes and delete the session. We have a lab for this video for this lab as well, so you can look into it. I think we're very short on time, so we'll just go through a few steps and questions if you might have, or you want to go through the troubleshooting. We are not planning to go through deployment and replica set as those are the next labs, but feel free to join our upcoming sessions. Or I think the deployment lab has the video here, which can help you understand it. On our YouTube channel, you can also find the videos regarding the deployment, or tell us in the comment if you have specific questions regarding it. We'll be happy to help you on those. We'll be adding more labs here and more scenarios which can help. We're also working on the guide section, which will help you. If you're looking for the certifications, you can go to Linux Foundation part and go through these guides to become a CKA and CKAD, so Certified Kubernetes Administrator, and certified Kubernetes application developer, we will have a session on the uh, tips, tricks, and information section session on the certification itself. We are planning to have advanced labs or intermediary labs in future on a workshop with them as well. This one was from the basic side of it. So we covered how to create a cluster, how to use the kubectl commands, and how to create the pod with the YAML format or YAML file. If you have any feedback, anything for us to change, improve, give us a comment in the Facebook, join our Slack channel, and join us. So if you go on the contacts, contact us, there's an option to subscribe to our newsletter and join our Facebook group and our LinkedIn group, or you can tell us the feedback via any of the mediums. So you can join our Facebook, tell us there, um, and collaborate with the others, or you can join our Slack channel, let us know, or leave a comment in the YouTube, and we'll be happy to help you. Okay, so I think we're right on time. I'll still continue for some more time on the Google Meet. I'll unmute there, and if you want to discuss anything privately, not with a bigger group, in a smaller group, which is on the Google Meet, sometimes people do not want to get recorded on the YouTube replay. Feel free to hang out on the Google Meet. I'll be happy to answer any of the questions you might have. So with that, thank you for your time, guys, and looking forward to work with you on the future sessions. We already have planned sessions for Docker and Kubernetes on November 19th. Also on our website, you can find um, all the sessions we have going to the learn and events. So all our workshops will be listed here. If you want to get free Microsoft certification on Azure AZ9 fundamentals or data platform or on the AI, feel free to sign up for these. Again, these are available to you, everybody who goes to the website. So thank you for your time and have a good weekend.